They're our friends.
You got half of it right, Nick.
DC and Judith, welcome to the show. How's it going?
Oh, it's time to publicly shame somebody.
Uh-oh. We got some mute buttons on.
Somebody's got their mute button on. We're not going to say who.
DC.
There we go.
There we go.
Can you hear me now?
The club couldn't handle him, so they're like, you know what? We're going to mute him for now because it's hot up here in the streets.
Well, let's start with you, Judith. Please introduce yourself for the audience.
Well, yeah, we are very excited to be here. I'm Judith Joseph. I'm a solutions architect with AWS. And I have my colleague here, DC.
Hi, I'm another solutions architect based out of San Diego. The weather is very nice here.
Great. You've got a friend in chat. He's
already gassing you up.
Yeah, named Todd. I believe Todd is out there. Todd is how you joined us today, I believe, right? Yeah, there you go. So you got to say hi to Todd.
Hi, Todd.
Hi, Todd.
All right, Internet, say hi, Todd.
Yeah, everybody say hello to Todd. All right, so we're going to be talking about... There, thank you, Internet. I appreciate that. We're going to be talking about managing IoT equipment. Yeah, and let's get into this around... Like, what are the issues that arise? I've never managed IoT equipment at scale, if you can believe that. You probably can't. You probably look at me and like, that guy's managing all kinds of IoT.
Yeah, he definitely swings a wrench around a lot. Definitely works, on heavy machinery.
Yes, this is a thinker's body. Anyway, yeah. So, what goes into managing IoT equipment? Like, what makes that difficult?
Scaling. Because, so before that, right, I also wanted to give a quick experience. I wanted to share a personal experience that I had. So it was the summer of 2022. It was really hot and the air conditioner unit at the house broke down. So as you all know, the next step is to call customer service. I called them, and you would be familiar with high volume calls. So I was on wait, and then finally somebody talked to me, got all the details, transferred to technical support. And then technical support went through some troubleshooting steps. And midway, the call got disconnected. And I realized I didn't get a ticket ID.
Sorry if I start breaking out in cold sweats, because this is like bringing back the darkest memories. A high call volume. Please hold. Your hold time is now 65 minutes.
Yeah, that was actually true. That was true, because I think many people were facing the same issue. So I called technical support again, and we went through the whole process again, at the end of which they said, we are going to send a field service technician to your place. I said, oh, that's great. So when is that going to be? In 3 days. Oh, okay. So in 3 days, it's going to be resolved, right? They said, we don't know what the issue is. So when he comes over there, he'll troubleshoot, and he will give you a better estimate, right? So 3 days goes by, and then he comes in and he takes a lot of time to troubleshoot, and he says, oh, I think I have narrowed it down to 2 issues. It could be the capacitor, or it could be the drain pump. I said, oh, okay. So when do we get that resolved? Right? He said, I need to order the parts, and they come in in 7 days. So I have a question for you. Was my customer experience positive, do you think, at this point?
I think someone in the chat already kind of answered that. Please hold until summers are over for the next available agent.
Okay. Yeah, it was not a good experience, but I could tell that the company and the field technicians, they were doing all that they can to get it resolved, right?
I'm sure they're frustrated by these types of situations too, that they have to go out, they don't know anything ahead of time, right? Like, I wish I could tell them over the phone that it's the capacitor, and I clearly know what that is on an AC unit. Obviously, my expertise is AC units, but no, I don't, and so I can't give them any of that information. So you're saying there might be a solution to this?
Exactly, and you nailed it, right? So from the OEM, original equipment manufacturer's side, what are the challenges they are facing, right? The turnover in their contact center is really high. And the people with the knowledge and the skill sets to address these problems, they may not have the knowledge and skill sets because the turnover is high. And the service level, they may not be able to keep up the SLAs, which is the service level agreements. And most of the time they send a truck, for example, field service technicians there, and up to 20% of that is unwarranted. They either resolve the issue in subsequent trips, or they may not, right? And added to that, there is new product innovation, right? So this is a very dynamically changing field. And for example, with connected equipment, right, like kitchen appliance, refrigerator and everything, there is a lot of innovation going on, and it is very hard to keep up with the products as they are being innovated, right? So there is what we did was we got the voice of the customer. We interviewed a lot of customers, got their input, and designed a solution guidance that we have published in the solutions library. And we had a lot of tenets when we were designing the solution. It should be well architected with the AWS services. Yeah, go ahead.
Can I ask you real quick, and this is for you, Todd, as well. Can you tell me more about the solutions library? What is that?
Can you beat me to it?
So the solutions library has a lot of curated solutions. We work backwards from the voice of the customer, right? And then we have prioritized use cases. And we have many different products in the solutions library. So there are capital S solutions, which are worked by engineering teams. And these are production ready. Security is taken care of. So there are the solutions. And then we also have guidance, which can be used for POCs, demos, so on. So each guidance will have an architecture diagram, well-architected pillars that explain why we made the design considerations and chose the services for that particular problem we are addressing. And it also has a sample code.
Can we look at the one? I know you've got a diagram, as you said, contained for the. Can we take a look at the diagram for the solution we're going to talk about today?
Sure. I'm sharing my screen.
Nick, find the button.
All right, there we go.
Okay, let me go through the flow, right? So this is the architecture diagram, and here we have some IoT devices. Now the IoT devices are going to publish to the IoT core over here, this box over here. And what happens? So the field devices. So when I say devices, these are machine customers. They are able to automatically send information to a contact center for issue remediation, right? So if the device detects an error and it publishes to an error topic, these errors are routed to the Lambda function. And then what we see is, at the same time, we are publishing an error to the error topic, right? But we say it is not an error. What if it is an anomaly? For example, we are seeing consistently high temperatures, high power consumption. That is not going to be reported as an error, right? It is going to be an anomaly. So we are going to see that trend, and we are using Amazon SageMaker Canvas over here for anomaly detection. And what we do is the Lambda is going to transmit all the metadata that is necessary, right? So say I was the field technician, I go in and collect all the details, right? Okay, what is the device? What is the error? And so on. But what we are doing is we are using the Lambda function to collect all this metadata, the timestamp, the location, device ID, and all of that, and sends it to the Bedrock agent. Now, the Bedrock agent, at the same time, so that was the error workflow. For the anomaly detection, we are using Amazon Firehose, getting all the data, putting it in S3. And also the event bridge rule triggers the Lambda. So SageMaker Canvas is doing the anomaly detection, but based on what frequency the customer wants, right? Okay, I want to see for the past 1 hour, has there been an anomaly? So we can use the event bridge rule to trigger the Lambda function to go do the check. And the Bedrock agent, I really love Amazon Bedrock agent because it makes the orchestration and it performs tasks perfectly. You give the instructions and it performs the tasks, right? So it receives the input from the Lambda function and it takes the appropriate actions. In our case, what is an appropriate action, right? So the agent is going to query a Q&A bot solution, like I had mentioned previously, right?
Right.
Q&A bot is a RAG-based solution, retrieval augmented solution, where you query and get answers from different knowledge bases. So it could be OpenSearch, it could be Kendra, it could be knowledge bases that come with Amazon Bedrock. So we get all that information, right? So Bedrock is sending the error information to Q&A bot. We get the result. And what it does next is it's going to create a ticket with the contact center.
Yeah.
In this case,
So, sorry to interrupt. Again, that's why they hired me, I guess. So this is a lot of information.
I'm getting called out in chat. Actually,
I'm more of a pop-up pictures kind of person, hands-on. We have this in a working environment. Like we could demo this, right?
Yep.
Awesome.
We demo it.
Do you know what we need to do?
Yep. DC.
Yeah.
No.
Nick,
We need to do a demo dance.
I need to share my screen. Do the magic.
Demo dancing for you.
Okay.
Kyle is more powerful at this than I am.
All right, the demo dance been performed.
We discussed about two different flows, right? One is you are getting the normal telemetry data. And then in case a device has an issue, it is like smart enough. It can like say like, hey, I'm in error state, take necessary actions. Now, when you are getting the normal telemetry data, it may seem normal, but there may be some anomaly, which is not in that error level. But looking at the data, like running the machine learning models, you can figure out there's an anomaly and you may want to take certain actions. What we are going to do here is we'll show the two experience. So if you see here, right, this is the AWS IoT console. And then I have my things or the devices registered here. The aircon 1, 2, 3, 4, these are different air conditioning machines, let's assume. And then I have a test client. Here I am injecting an error like, hey, this particular device has a compressor failure.
Right. So MQTT is a protocol, and the IoT devices speak that protocol and send sensor data over that to this right here. Is that
perfect?
Okay.
Now, as this error being triggered, Judith was talking about like, hey, there are certain actions that will be taken care by Bedrock agent. It will do the magic, the orchestration. So what it does, it first looks at the knowledge base. So this is a sample knowledge base we created like, hey, these are different error codes. And for these error codes, you take certain actions, right? If, by the way, I got a call.
Uh-oh.
Let me
take a call right now, DC?
Yeah.
That's so rude.
Control violation notification. Here are the details. Unique ID is 784506F18F4885E9BD7CAM2C50B5C1.
Boy, I hope you got that ID.
Error code is E3. Error code is E3. Troubleshooting steps in order. 1. Verify power supply to compressor. 2. Check compressor winding/resistance. 3. Test capacitor and relay. Please attend to the site immediately.
So basically what Bedrock agent did, it looked at this particular troubleshooting document and it found like, hey, I have to log a ticket and it's a compressor failure, call the site operator. So when we are logging the ticket being logged in this case in the DynamoDB table. So this is my DynamoDB table where this is the Q&A bot device error. And if I see for aircon 3, this particular ticket being logged. Now, we are using unique ID as the ticket ID. In real life scenario, we'll probably have a smaller number so that when you get a call, you understand what it is. But you also get an email. So that way, you can basically see what kind of like error it is, the unique ID or the ticket ID, which device is, say, having the fault, so on and so forth. And then you can always go back to your say database. In this case, it's a DynamoDB. You can have a front end and you can see like what's going on with the device. This is one flow. We said like there is another flow, which is like you're getting the normal telemetry data, but then in the telemetry, there is some anomaly. So let's look at the knowledge base once again. So in case of anomaly, right, typically here we are basically error coding it with letter W, which is warning. And then in this case, it's a high electricity consumption. And then it has a troubleshooting steps and whatever action that you need to take.
So do you see this, like in our example here, this might be, you detected a fault earlier, right? You know, action needs to be taken immediately to go fix whatever happened. When you detect an anomaly, you don't necessarily know that a fault has happened. You just know that something is strange and it warrants more investigation and maybe some follow-up, right?
Exactly.
Okay.
Exactly. So in that scenario, first thing what you want to probably figure out, like, hey, where is this device located? Like, what's going on? Can you tell me a little more about the device? And then I can see what's the issue. So this is the chat bot, and this Q&A bot, the chat bot, it is interacting with the different knowledge bases as well as the Bedrock agent. And here I can go and say like, hey, I got an anomaly for a device AirCon1. Can you tell me? Sorry.
This is the stream today where we challenge people to type live. I think, Kyle, this has been a recurring theme here.
I'm just thinking about how I disagree that the first thing to do would be turn down the thermostat.
Okay, next one I'm not right.
Don't touch the thermostat.
So see, it is saying like, hey, this AirCon device is based out of like, it's deployed in the San Diego location. John Doe is the site owner. And I know like what action, like if I have to make a call to the site owner and take an action, I can do that. Now I can also go ahead and ask a question like, hey, can you tell me little bit about this anomaly? So in this case, like I'm giving the unique ID or the ticket ID and the device name and say like, hey, tell me the details. What is happening behind the scene? That's where I want to show you the agent. So in the agent, we have given the instructions like if you get certain things, you take actions based on that. If it's an error and I'm sending you the error details, you go to this error section and then log it based on the knowledge base, whatever steps being defined. If it's anomaly, again, look at the knowledge base and take necessary actions. In this case, it's a user query. I want to figure out what's going on with the device, right?
So this is sorry to cut you off, DC. This is what Judith was showing us in the diagram earlier, where the prompt, gets entered, but then also through Bedrock knowledge bases, it can query about data that is like happening as these IoT sensors are sending in data and things like that.
Exactly.
Right?
So if you see in this case, first it is querying the error table, my DynamoDB table for that unique ID to figure out like, hey, so if you look at this error table, right, for AirCon1, we have this warning, and then there is anomaly start and end date. So it is picking up that start date and end date, and then it is looking at the telemetry data, which is in the data lake, to find the telemetry for that time window. It is also looking at the knowledge base and figuring out like what are the different troubleshooting steps, what can be the reasons for like this particular anomaly. And then if a dashboard is available, so it is also pulling out that dashboard and responding back to the user. So if you see, it has responded, right? Hey, this is error code W1. It's an HVAC system. These are few of the things that may have caused the issue. Adjust the thermostat, blah, blah, blah. It also gives you a summary of the telemetry data. Like say between this time to this time, I see the wattage has increased from 1,000 and 1,400. So typically to maintain the temperature, which is like we have set the set point as 24 degrees centigrade for the like internal room temperature, you probably will be consuming around 800 to 1,000 wattage. So during this time window, it went up, which is an anomaly. And see, this is a nice telemetry dashboard. Let's click on that. It is basically pulling up the QuickSight dashboard. And these are parameterized, right? So you are basically sending those parameters based on your like anomaly start date and end date. So agent talking to the Lambda, and Lambda is sending this and then pulling up this dashboard. And as you can see, the green line, it is basically the set point, which is 24 degrees centigrade. The dark blue line is the room temperature, which is ranging between, say, 24, 26, which is fine. Outside temperature is the sky blue line ranging between 40 to 50. But if you look at the red line, right, that's where the wattage increased during that window. And it's on the, say, y-axis on the right side. And it's above 1,200 wattage at certain points, right, which triggered this anomaly.
Are we sure the anomaly isn't that it's set to 75 degrees?
It can be like if for some reason your room temperature is increasing very high and it is not able to bring it down to the set point, it can be an anomaly as well, right?
That's that San Diego weather, DC.
That's the San Diego weather. By the way, this temperature is in degrees centigrade.
Yeah.
Fahrenheit you were talking about. Sorry, I missed it.
I was going to say it's unfortunate that we'll never know what the temperature was because there's no way of knowing what Celsius is. We just don't know. We don't have the technology to know Celsius. We only know Fahrenheit here because Kyle and I are based in the U.S. That's it's the only measurement. No, this is incredible, and we've got about 1 minute left. DC and Judith, I want to give you both an opportunity to talk to the audience before you have to leave us about the solutions library. I think this is really like a great example of what's out there in the solutions library. But for anybody watching, why should they go to the solutions library right now, which they should? Tell us why they should and what can they expect to find. What are some other cool things that you would love to highlight from the solutions library?
So there are many solutions, right? They are arranged by domains, technical domains, by industries, and these are popular use cases. And this particular solution, right, DC showed it for a residential unit. Now, if you think big, what about the industrial unit, right? There are pumps, robots. So you extend the use case, the workflow is the same, and so you can build on top of this.
I love it. Everything's pre-built for you, and then you can extend it however you need. That's powerful. Well, thank you both for joining us. We really appreciate you being here.
Yeah, glad to be here. Thank you.
All right. Thank you. See you again.